Hi, I'm Eric Perel. I'll be your guide for a tour of the Aerospace Engineering Department laboratories today. The laboratories are used for any number of things, ranging from coursework to student projects of various kinds for research or for club projects or professional competitions. We'll start here in the Structures and Instrumentation lab, which does have a course dedicated to it. The S&I lab is used for testing typically structures, aerospace structures to failure. One example is right here. We have a composite filament wound pressure vessel that was pumped up and tested to failure, and you can see the result here. This was done in our what we call the boom box, which is a hydrostatic test facility back here. The boom box was first built about 12 or 15 years ago. It's about a 5-foot cube, steel cube with 3/16-inch plate steel all around it. It's made for containing small explosions, essentially. We can attach a pneumatic line to a pump system that's inside of the container and essentially pump up a pressure vessel of some sort with water to test it to failure. That's one example of what we do. We also have some structures up here on our test apparatus that we hang various weights to and measure deflections and stresses and strains to failure. And you can see some other equipment set up in there. We also do some research with grad students involving acoustic emission non-destructive testing of things like pressure vessels, where they attach microphones, small microphones to pressure vessels and measure the output, the acoustic signature, up until failure. And by doing so, they can, through neural network back propagation analysis, they can make predictions within about typically 5 to 10% of the cyclic loading to failure on any particular composite structure. Okay. This is our supercomputer cluster. We call it Zeus. This was actually a project between the College of Engineering, College of Aviation, and the College of Arts and Sciences. It was funded through an NSF grant to the tune of about $750,000. The cluster has 256 Intel microprocessors, and it's used for computational fluid dynamics and weather prediction, typically, through connections to other labs throughout the campus. And we'll be in the computational fluid dynamics, or the CFD lab, upstairs in just a few moments. This is our computational fluid dynamics, or CFD lab. We have about a dozen workstations that boot in Linux or Windows. They run a number of commercial and research software package for CFD and grid generation. And they are connected to our supercomputer cluster downstairs, where we can run large parallel jobs. We also have a small parallel cluster with about 20 nodes on it for running smaller developmental jobs, as opposed to the production jobs which we run on the supercomputer. Some of the commercial packages that we have available are ANSYS, CFD, and Fluent. We also have GridGen and Pointwise for grid generation and graphical post-processing. Okay. Now we're in the composite materials lab, which is used for laying up various composite structures for aircraft and spacecraft and such like. Here we have an example of something that was done several years ago by a group of students. This is a fiberglass overlaid balsa wing. We keep the materials on rolls back here. Typically the material is laid up by hand and then impregnated with a matrix material, an epoxy, for example. We have a vacuum bagging system here. These are all attached to vacuum lines. And then for smaller structures that need to be cured at high temperature, we have an oven back here where we can bake the structures at about up to 300 degrees Fahrenheit or so. The vacuum lines also access the inside of the oven, and there's an exhaust vent over top for removing hazardous fumes. This is the materials testing laboratory. We have a fairly vast array of equipment for stressing in tension or in compression or even in torsion different material samples. So it's used for testing materials to failure and recording the stresses that they can withstand. So I'll just walk you along and we can take a look at the various equipment. And over on this side of the lab, we have 2 ovens for heating up materials to high temperatures. I believe they're capable of something like 1,000 to 1,200 degrees Fahrenheit. And lastly is the Tinius-Olson impact testing machine. This is Mike Sheppa, one of our graduate teaching assistants here in the wind tunnel lab, and he'll explain a few things about what goes on in here.
All right, welcome to Embry Riddle's wind tunnel Daytona Beach facility. Here we have 3 main tunnels that we work with, primarily junior year in a class called Experimental Aerodynamics. This is our main instructional tunnel over here. Reaches speeds up to 140 feet per second, which is slightly over 100 miles an hour. We can test different flow quantities in here. We measure horizontal pressure distribution, which is the experiment that's being set up right now. We can also measure a number of other parameters with our data acquisition system underneath, measured by the computer, coefficient of drag, lift, any other parameters that we might need. And for flow visualization, we have 2 smoke tunnels over here on the other side. That's a 3D smoke tunnel right over here, and then a 2D smoke tunnel over in the back. All 3 are operational, and your junior year, you spend some of your good amount of your time in here performing experiments. And that's about it. Bro?
Okay. We're here in the machine shop with Bill Russo, our laboratory supervisor. Bill will show you some of the equipment back here.
Okay, what we have in this room is manual equipment for machining components for the different labs and the different student groups. What we have over here is our manual machining centers. We currently use this equipment to support the CNC equipment in the other room, but what we'll do in this room here is the students will come in with drawings such as this, and we'll go ahead and we'll cut them on the manual milling machines. We have 2 of them. They have readouts on them. Some of the students are actually allowed to come in here and operate the equipment with some training. Other equipment that we have in this room, we have other support equipment like our bandsaws. We do have a manual lathe for doing round work. Over here we have a surface grinder for doing precision grinding of steel components. We do have hardware as well to support the work that we do. But mostly this room, like I said, is used for support for the CNC manufacturing lab that we have. We also keep an ample supply of tooling in here.
We're outside the gas turbine laboratory now. The front of the laboratory is graced with pictures of a lot of the projects that go on in here, mostly graduate student research projects. One project that we worked on several years ago was a jet dragster, a redesign of the engine on a jet-powered dragster car. These are pictures of a gas detonation engine for trucks. And over here we have some depictions of CFD and materials and finite element calculations of turbine blades. We're inside of the gas turbine laboratory now. On my right is a suite of graduate student offices, and around we have static displays of different types of gas turbine engines, turbofans, turboprops, and turbojets. Not all of them are operational. They're mostly for for static display. We tour some of our other classes through here at times for the students to get a first-hand look at various turbo machinery. This is Steve Murphy. Steve is our student lab assistant here in the Computer Numerical Control Manufacturing Lab.
Right behind us you can see one of our primary machines. This is a Haas VF2. We have a 4-axis mill here at our disposal. We can do all sorts of combustion chamber components. This supports all of our various club projects. And also on the left you see our Haas tool room lathe. We do a lot of, again, combustion chambers, drive shafts, a lot of various components out of steel, copper, aluminum. And around us you can see all sorts of materials that we have available. A lot of our materials on the rack over on this wall, so clubs can come down and get their jobs processed here at our facilities. And also we have a 3-axis CNC router over here, which we can do foam models and MDF models for composite layup. All the aircrafts you see on the walls are all done on that CNC router you see there.